All right. Rectangle. We know this is a rectangle, so we can use our definition and our theorems that we have. And we want to prove that the diagonals are. Now, so let's first draw in the diagonals, because if I am proving the diagonals are, clearly I need both diagonals, so we'll draw those in. Now, I already know that the diagonals are bisecting each other, because I have proven that a rectangle is a parallelogram. And that's all I know. So if you look at these, I hope you don't think that both of those angles look equal to each other. We definitely have one that's bigger than the other. So it doesn't appear to be like a rhombus where it cuts the interior angle in half. But these two, at least in my mind, look equal to each other. So again, with geometry, you start with a look like, and then you prove that it's true. So we want to prove that the diagonals are congruent to each other. Now, in order to do that, I need to make sure that the triangles that I choose have the diagonals as parts of them. So if I choose this triangle here, this is not the whole diagonal, and that's not the whole diagonal. So that's not going to be very helpful. If I choose this triangle, and then this white triangle up here, that's not going to be very helpful, because I won't be able to prove anything about this triangle, or this diagonal. So what I need, I hope you can see this, is I need to prove, let's use colors. I need to prove that this yellow triangle is equal to this orange triangle. Because if I can do that, then this diagonal on this triangle will be equal to this diagonal on that triangle. So that's what I need to do. How? Let's go ahead and see what we can do. Obviously, we have our given. Now, I need angles and I need sides. So I know that the definition of a rectangle is that all the angles are equal to each other. So this angle in my orange triangle can be equal to this angle in my yellow triangle. Now, I'm going to say equal 90 to each other as well, because I don't know if I'm going to need it, and it would be nice to not have to go back. So it's not just equal to each other, they're very specifically equal to 90 degrees. So I have one angle, yes. I need some other things. So this one here, do you see this line in this orange triangle and this line in this yellow triangle are equal to each other. They are overlapping. They are reflexive. So I've got 2 out of 3. I've got a side and I've got an angle. I need probably another angle or a side. So, well, not probably, I need one of them. I know, hopefully you guys know from past experience, that these sides are equal to each other. The reason, though, in a rectangle is it's a theorem, not a definition. So the theorem states that a parallelogram has opposite sides are congruent, and I've already proven that a rectangle is a parallelogram. So I have that true as well, and that should do it. Check it out. Side, angle, side, side, angle, side. Now, oops, I wasn't thinking when I did it, I was trying to hurry. So A and B go together, A and B, and then C and D go together, and then so A, C, D, and then B, D, C. So those are the ones that match. So I have my 2 triangles congruent, and this is a part of the orange one, and that's a part of the yellow one. Oh, happy days. So I'm going to say AC is then equal to BD. Now let me give you some color coding here. So ACD is our yellow triangle, and this is the hypotenuse of the yellow triangle, and BCD or BDC is the orange triangle, and this is the hypotenuse of the orange triangle. So that's where they come from, And my reason, be congruent triangles give me congruent parts. And that is helpful because that will tell me that the diagonals are congruent to each other. And our reason will be definition of, the reason I chose these specific ones is I knew they were diagonals, so I'm using the definition of diagonals to do it.